Because of their straight teeth, spur gears are some of the easiest gears to model and manufacture. They're great for learning about gears. They're the cheapest gear to produce, they work really well at low speeds, and they're beginner friendly. But the way their teeth are designed makes it easy for them to slip and lose grip with each other. When they reach really high speeds, they get really noisy and start vibrating. An upgrade to the spur gear is the herringbone gear, which is basically two helical gears mirroring each other. Their teeth engage gradually, so they operate really smooth. They have a really high load capacity, and because of their V shape, that prevents the teeth of these gears from sliding out of each other's grip. But they're a little bit more advanced to design. In this video, we'll modify the spur gear and turn it into a herringbone gear, making it more efficient and better to use in a hand-cranked phone charger. We'll also add some spacing to prevent the gears from rubbing against each other. Let's start by creating a new hybrid design and then adding a spur gear. As you can see, I've already added the spur gear command to the Create panel in the Solid tab of the Design workspace. But if you haven't, click Utilities, Add-ins, Scripts and Add-ins, and hit the play button next to spur gear. Leave all the settings as is. We're about to create a spur gear with 24 teeth. Next, create a sketch on the top surface of the gear. Making sure that 3D sketch is checked, select the line tool, and from the center of the gear, draw a line that goes up vertically, perpendicular to the surface of the gear. I'm setting the length of this line to 25 millimeters. We'll use this line later for the sweep tool. You can now click Finish Sketch and make the spur gear component invisible. We don't need it anymore. We only needed it to create the outline profile for the spur gear, which got generated when we created a sketch on the top surface. Now use this profile to create a sweep. Use the vertical line you created as the path that the sweep will follow. Set the twist angle to 15 degrees. And you've just created a helical gear. Before clicking OK, make sure you set this object as a new component. To turn this into a herringbone gear, just mirror this body using its top surface, and make sure you set the operation to join. I've repeated this process to create a second herringbone gear that has 48 teeth. Pause the video and do the same. What you see on the screen now are two herringbone gears that both have a twist angle of 15 degrees, but their teeth don't match, and that's going to be a problem when it's time to align their teeth. You'll notice the one with the larger circumference, it looks like its teeth are more stretched out. That's because, although both gears twist at 15 degrees, the one with the larger circumference, the teeth on the outside have a longer distance to travel, which makes them appear more horizontal. To find what the twist angle each gear with their different circumferences would need for their teeth to match, we can use this equation, entering some unique values about the gear. An explanation of how this works can be found in the description below. I took the liberty of creating this website, which spits out a twist angle based on the values you enter. For my smaller gear, the height of half the herringbone gear is 25. That's the length of the sweep path. The twist angle value I'm entering is 15, and the number of teeth is 24. I'll take this value that's being outputted and copy it. And then in Fusion, I'll find the sweep operation for this small gear, edit it, and paste in the twist angle value. For the bigger gear, the height is also 25. The twist angle is also 15, and the number of teeth is 48. I'll copy this output and edit the sweep operation done on this gear, pasting in the new value. Now that we know how to make matching herringbone gears, let's make a herringbone gear set and add a cylindrical spacer in between to prevent the gears from rubbing against each other. With the small gear being the active component, I'm going to create a sketch on its top surface. I want the cylindrical spacer to be the same size as the circumference of this gear while looking at it from the top. So to create that circle that I'll use to extrude to create the spacer, I'm going to project this entire gear's outline on the plane where the sketch is. Then I'll click Finish Sketch and extrude this circle up. I need this entire circular outline. Exclude the hole in the middle and extrude this circle up 50 millimeters. On the top of this spacer, I want a copy of the big gear. What I'll need to do is find this body of the big gear and copy it, and then find the component with the small gear, find that bodies folder, and paste the big gear's body into the bodies folder where the small gear is, so that both of those bodies will exist in the same component, so they'll move together. Then I'll move this body up toward the sky so I can see the bottom of it. So I'll be able to align the bottom center of the big gear with the top center of the small gear using the Align tool. Now take a look at the big gear and the little gear, more specifically the direction of their teeth. In order for herringbone gears to be able to move each other, their teeth have to be facing opposite directions. One's teeth have to be pointing clockwise, the other one's teeth have to be pointing counterclockwise. Otherwise, their teeth will run into each other and they won't align. There are a few ways you could set the teeth on the other gear to face the opposite direction. You could either flip the gear upside down, or you could mirror the gear like I'm doing in the video, or more easily, you could edit the sweep operation and change the value of the twist angle from being positive to being negative, or vice versa. Now I'm toggling the visibility of the gear component with teeth facing the wrong direction. I'm going to make that one invisible. After creating this mirror, I'll slide the gears close to each other. And then, like before, create cylinders at their centers as new components that will be grounded to their parent, so I can create revolute joints between the gears and the cylinders. With the grounded cylinder poles in place, I can now create revolute joints between the gears and the poles. I'll be using an as-built joint for this first revolute joint, which requires me to select the two components that have already been built together and the one location where both of their snapping points will meet. Once both of these gears are together and aligned, I can combine their bodies. I'll do the same for the other gear as well. Create an as-built joint. And it looks like as I'm trying to drag the gears and make them rotate, they're not moving. And that's because I forgot to ground the poles. So that's what I'm doing now, grounding the poles. So now that the gears are free to move and can rotate, I'm going to align their teeth to prepare them for the motion link. The first joint I selected is inside the big gear, which has 48 teeth and is twice the size as the small gear. So when the first gear makes 1/2 of a rotation, the second gear, the smaller one, should make 1 full rotation. In other words, when the first gear turns 180 degrees, the second gear, the smaller one, should turn 360 degrees in the opposite direction. Now I'm doing a section analysis just to see that my teeth align all the way through from top to bottom. Next, I'm going to create a second gear set with teeth facing the opposite direction. Create an empty component, which will later contain the body of the new gear set. In the browser, find the body of the original gear set and right-click it and copy it. Then right-click and paste the gear body into the new empty component. The new gear's teeth are facing the wrong direction. I'm going to mirror this gear set to create a copy with teeth facing the correct way. With the second version generated, I'll find the body of the backwards one in the browser and remove it. Now I can align the center of the new gear set to the pole it will revolve around. Using the Move tool, I'll move the new gear set downwards until its teeth align with the gear it will be in contact with. With the gear set in place, I'll create an as-built joint between the pole and the gear set. Next, I'll create a motion link between this new joint and the joint of the gear in contact. Create a section analysis to make the teeth visible. With the teeth visible, you can now align them to prepare them for the motion link. Now with the teeth aligned, create a new motion link. As shown in this video, I'm clicking the joint inside the smaller gear first. When this one turns 360 degrees, the gear it's in contact with should only turn 180 degrees. And that's pretty much a wrap on how to create herringbone gears, which are much stronger than spur gears, and also adding spacers to prevent them from rubbing against each other. See if you can scale up this project a little bit and add more herringbone gears to the back of the ones that I've already added.